Oh, that's poor wording. Okay, so number 41 in 4.1 asks, calculate the rate of change over the interval 1 is smaller than x is smaller than 2 if f of x is 3 to the x power. And what they should have said is calculate the average rate of change, right? So why am I complaining about their average?
Because it's an exponential and it's always going, like it's getting bigger.
Yeah, so this thing, right, looks like exponential growth, yeah? So, boom, something like this. Okay, and maybe 1's here, right, and 2's there. The rate of change is the slope at which this sucker's going up, right?
Yeah.
At 1, it's not going up that fast. At 2, it's going up faster. You guys see that? So there is no there's no global rate of change here, right? There's an average, and we could maybe talk about an instantaneous at each end. You guys see that? How do I figure out the average? Like, what's a rate of change?
Two
Find
instantaneous.
The first point, and the one point you know, one point you don't know.
Two
Or-
instantaneous points in
Yeah.
between is the average.
Okay, good. So there's 2 points here, right? There's 1 here and 1 here. So what's this point here?
1 comma 3.
Yeah, so 1 comma f of 1, which is 3 to the first power is 3. And then this other point up here is 2 comma 9. And the rate of change I'm talking about is the, is the rise over run. That's really out of this triangle or the other one, right? Which is going to give me the slope of what line? The line that, good, the line that goes between those two dots. You guys see that? Cool. Okay, so what's the rise then? 6. What's the run? 1. So the rise is from 3 to 9, right? So we went up 6, and then from 1 to 2 we went over 1. Just make sure you draw the picture, or don't screw up the signs in the y2 minus y1 over x2 minus x1. You guys cool with that? I don't care which formula you used or whether you draw a picture or not. I would really recommend drawing a picture so you don't screw it up, but that's me. So what's your answer for this? 6. Yeah, so the average rate of change is 6. And if this was a population model, right?
It would be 6 whatevers.
This would
whatever
be
time.
6 whatevers per whatever is the time unit. See that? This would be a weird population, right? Why would this be a weird population model? What's the population at time 0 here? 1. So this is one thing, right? This starts off as one thing and triples every time unit. That's a weird critter.
Maybe it's cell. It's a cell.
The cell usually splits into 2.
Yeah, cells double.
It's a strange cell.
It'd be weird if they tripled, but
Maybe it has a
Maybe
genetic.
it's a
I'm-
gamete cell. that's-
there's probably a biology model where this works, but it's not the one we operate with usually. Cool? So sometimes you get away with the 1, right? By just assuming that it's 100%. And so what this would be is the population.
600?
Yeah, this gets a little weird when you're talking in percentages, right? So I would recommend you stay away from these because interpreting them is a little bit rocky.
Yeah.
Cool? I think it's probably better for now if we just keep this as 6 whatevers per time unit.
What you really need is an A value.
What do you mean 600%? Because it's 6 times? I don't know.
Okay.
Sorry.
So this would be an increase of 600%, but we don't mean of 600% of the population that we had at time one. What we mean is an increase of 600% of whatever the new, or whatever the starting population is. So to interpret this, you have to go back to whatever the population was at time 0.
And that would be the one.
And then we went up,
It's from 1 to 6.
which is an
600%.
additive thing, right? The up 600 is an additive thing. And we're not talking about 600%, which is usually a multiplicative thing. You guys see that? That's why I'm saying
Stay with it.
just stay away from percentages as increases. That's hard. You will, of course, see lots of people do this on the news, and usually they're totally off base.